another episode of Sci-Connect. I am Teacher Nell, your science teacher for today. Are you now ready to learn? Let's start! Hello grade 8 learners! Welcome to our video lesson for week 6, which is all about atoms inside out. In the previous video lesson, you learned about everything in this world is made up of matter, which in turn is made up of atoms. These atoms are made up of the same atomic particles. Atoms are neutral, meaning for every proton in the nucleus of an atom, there is a corresponding electron outside the nucleus. The atom of one element differs from the atoms of another element. You have also learned that the subatomic particles of an atom is the atom wherein you are going to determine its number of protons and electrons. Now, are you ready to learn about the opposite side of it? By determining the atomic number and mass number given the number of protons, electrons, and neutrons? So, let's start with our lesson. The most essential learning competency for this lesson is to determine the number of protons, neutrons, and electrons in a particular atom. The specific objective is to determine the atomic number and mass number of a given element. But before we proceed, let us first define some vocabulary list that is part of the lesson. First, we have mass number. Tells us the number of protons and number of neutrons in an atom. Atomic number tells us the number of protons as well as the number of electrons. Isotope is an atom of the same element having the same number of protons but different number of neutrons. Before we start with our lesson, take the following test first to find out how much you already know about the topic to be discussed. Number 1. Chlorine has an atomic number of 17 and mass number of 35. How many neutrons are contained in an atom of chlorine? A17, B18, C35, D52. Number 2. An element has an atomic number of 84 and a mass number of 210. To describe the element correctly, which number of particles will it have? A. 84 protons and 210 neutrons. Letter B. 84 protons and 84 neutrons. Letter C. 84 protons and 126 neutrons. Letter D. 84 protons and 126 electrons. Number 3. If two atoms of uranium have different numbers of neutrons, which other properties would be different? A. Number of protons, B. Mass number, C. Number of electrons, D. Atomic number. Number 4. Which of the following pairs is example of isotopes? A. Superscript 35X subscript 17 and superscript X subscript 18. Letter B. 35 superscript X subscript 17 and 37 superscript X subscript 17. Letter C, 35 superscript X subscript 17 and 37 superscript X subscript 28. Letter D, superscript 35X subscript 17 and superscript 35 subscript 17. Number 5. In an atom of 65 superscript Zn subscript 30, the respective numbers of protons, neutrons, and electrons are blank. A. 30, 35, 30. B. 30, 65, 35. Letter C. 30, 65, 35. Letter D. 65, 35, and 30. To better understand about this lesson, let's start by performing the first activity. In this activity, you are going to, number 1, determine the number of protons, electrons, and neutrons in a particular atom. Number 2, define mass number and isotopes. And number 3, differentiate atomic number from a mass number. Let's do this. Complete the table found in the next slide with the needed data using the first sample as your guide and answer the guide questions that follow. I will have to flash on screen the table. This is the incomplete table wherein you are going to supply the missing number. Remember, the first two elements are the examples that you have to follow as your guide. Carefully analyze, and please don't forget to write your answers in your notebook. You can pause the video for a while so that you have enough time to think and analyze what is asked in the given table. Guide questions. Number 1. What subatomic particles is different in every element? Number 2. Is atomic number the same as a mass number? Number 3. What is mass number? Number 4. Differentiate atomic number from mass number. Keep in mind that mass number tells us the number of protons and number of neutrons in an atom. Mathematically speaking, mass number A is equal to number of protons plus number of neutrons, or A is equal to atomic number Z plus number of neutrons, or in superscript O. The number of neutrons is equal to mass number minus the atomic number, or the N superscript O is equal to A minus Z. So remember this equation. The mass number A of an atom is the total number of protons and neutrons called nucleons in the nucleus. The mass number is the nearest integer or whole number of the atomic mass, which is known as the atomic weight in an AMU, or atomic mass unit. Remember that the mass of atom is concentrated in the nucleus because the relative mass proton and neutron are both equal to 1 AMU. So they are always relative mass of proton and neutron because both are equal to 1 AMU. And also, a given element has fixed atomic number, thus all of its atom has the same atomic number. Atom of the same element, however, may have different mass number. These atoms have varying number of neutrons, thus their mass numbers likewise vary. Atoms of the same element with different mass number are called isotopes. Again, if the atoms of the same element but it has different mass number, therefore it is called an isotope. So example of these are given in the table below. For example, the carbon. We have the isotopes for carbon 12 and 13. For hydrogen, we have also 1, 2, 3 isotopes. To strengthen your knowledge about this lesson, let's learn more. Fill in the table with missing data. Let's proceed to post-tests. Number 1. An atom with 4 electrons, 4 protons, and 5 neutrons has a mass number of blank. A4, B5, C8, D9. Number 2. What is the number of neutron in an element of potassium? A19, B20, C39, D58. Number 3. Chlorine has an atomic number of 17 and mass number of 35. How many neutrons are contained in an atom of chlorine? A17, B18, C35, D52. Number 4. An element has an atomic number of 74 and a mass number of 184. To describe the element correctly, which number of particles will it have? A. 74 protons and 114 neutrons. B. 74 protons and 154 neutrons. C. 74 protons and 126 neutrons. Letter D. 74 protons and 110 electrons. Number 5. If two atoms of gold have different numbers of neutrons, which other properties would be different? A. Number of electron, B. Number of proton, C. Atomic number, D. Mass number.
Congratulations, learners, for finishing the visual lesson. I hope you enjoyed learning with me today. Remember, learning is fun with Sci-Connect.